Continuing on with the example with the pulse rates. Let's change it up a little bit. Suppose I want to know the percent of U.S. women that have pulse rates less than 80. How could I determine that? Well, first we need to figure out how many standard deviations away 80 is from the mean. And if we look at our diagram we drew from the 68, 95, 99.7 rule, 80 is not a definite stop along the axis. We jump from 74.5 to 86.7. So if we tried to judge where 80 was in this interval, it's somewhere in here. Looks like not quite half, maybe halfway between 74.5 and 86.7. So we need to figure out how far it is away. So 80 minus 74.5, 80 is approximately 5.5 beats per minute above the mean. Now, what fraction of a standard deviation is 5.5? Well, this is going to bring us to what we call a standard score. This is going to allow us to figure out exactly how many standard deviations our pulse rate of 80 is above 74.5. Now we know in just beats per minute it's 5.5 beats per minute above. Our standard score is Z equals Y minus Y bar divided by S. Now let's remember, Y bar is our mean and S is our standard deviation. So if we insert the beats per minute we're curious about, that is 80, we'll take our 80, subtract off the mean of 74.5, that gives us the 5.5 we were speaking of earlier, and we'll divide by our standard deviation, 12.2. So basically what this standard score tells us is what fraction is 5.5 of our standard deviation, 12.2. Well, it looks like it's 0.45. As we mentioned earlier, just about almost half. So keep in mind that when you divide these out, the beats per minute, that is the unit, disappears. So this is indeed a standard score. A pulse rate of 80 is 0.45 standard deviations above our mean. Now that's great, but what do we do with this information of 0.45? You know, when our data doesn't fall exactly 1, 2, or 3 standard deviations above or below our mean, all we had before was the 68, 95, 99.7 rule. There's a more sophisticated table called Table Z, and it's in the appendix of our book, in Appendix D, and actually provides us with what we call normal percentiles. And lots of calculators and computer packages do this as well. I prefer the table itself, the paper table. So I'm going to show you how to use the normal table in the next few slides. Now keep in mind, in order to use Table Z, you have to first convert your data, whatever unit it might be in, ours is in beats per minute, you have to convert your data to a Z-score, or what we call our standard score. Alright, what percent of U.S. women have this pulse rate less than 80? Well, we just discovered that 80 is 0.45 standard deviations above. So just underneath this axis where beats per minute is primarily here, I'm just reminding ourselves that that was a standard score of 0.45. Now, if we look at our Z table, you can pull yours out and look along with me. You see we have our Z table here, standard normal table. Now the standard normal table is divided into some interesting parts. The first column of the standard normal table, now these are positive values here, is the ones place followed by a decimal and then the tenths place of the decimal. And then the first row of the standard normal table is the hundredths place. So we're going to actually try to build the number 0.45 from the proper row and column. So if we want to find 0.45 in this table, we will look up on the row 0.45. You just saw the red arrow, pardon me, 0.4. You just saw the red arrow come in right at the row 0.4. Now, we'll cross-reference this with the proper column. Now, our hundredths place is 5. So we're going to come in at 0.05 vertically. So together this builds the number 0.45. This circles in on or converges in on the number 0.6736. This is what we're going to use to convert to our normal percentile. Let me show you how it works. Back to our image. This number 0.6736 represents that fraction of the normal curve that's shaded in this turquoise color. Thus, if we take the 0.6736 and convert it into a percent, it tells us that 67.36% of women have pulse rates less than 80 beats per minute. Now this is a little different and more sophisticated than our 68, 95, 99.7 rule. Let's try another. What percent of U.S. women have a pulse rate above 95 beats per minute? It's a slightly different question. We want to know to the right of 95, and you can see here I've shaded in with this sort of light blue color to indicate we're interested in this area to the right of 95. Now to me it looks like it's going to be a rather small percent. It doesn't really cover much of the curve, so we're going to expect a smaller percent for this answer. So the first thing we need to do in order to figure this out is to convert our pulse rate that we're interested in, that is 95, we need to convert that into a standard score, into our Z-score. So here's the math. We take the 95, that is our stopping point along the horizontal axis. We subtract off the mean, which is the center of the distribution, and we divide by 12.2. So 95 is 20.5 beats per minute above our standard deviation, above our mean. If we divide that by the standard deviation of 12.2, we arrive at a standard score of 1.68. Let's see if this makes sense. There's one standard deviation, there's two standard deviations. We can see 95 falls somewhere between 1 and 2 standard deviations, a little bit over half at 1.68. So this seems really appropriate. After we have the standard score, of course, I can see here that again my units cancel out, so we know that this is a unitless number, the Z-score is. We'll go look it up in the normal table. Here we are again at the normal table. This time our Z-score is 1.68. So we're going to look for the row that has 1.0. Pardon me, not 1.0. What row are we looking for? Think about that. We're going to look for the row where it has the first part of the number and the one digit after the decimal, 1.6. So we're going to go to row 1.6. There it is. Then we're going to find the proper column by grabbing our hundredths place, 8. So we're going to go to the column 0.08. So again, I'm building the number 1.68, and we can see that they arrive and they both point to the number 0.9535. Keep that in your brain, 0.9535. That is the area to the left of our Z-score of 1.68, which coincides with 95 beats per minute. This is not the area I'm interested in. I'm actually interested in this turquoise area, no, I shouldn't say turquoise, light blue area over here to the right. So how would I determine what is that little value over there? Well, keep in mind that the entire curve can be represented by the number 1. The area of the entire curve is 100%, which if we think about that as a proportion is 1. So I want to know on the opposite side. So if I take 1 and subtract off this area I'm not interested in, the white area, that'll leave me with the difference, which is this small light blue shaded area of 0.0465. Now if I convert that to a percent, of course there's the arrow indicating that's the area we just found. If I convert that to a percent, we get 4.65% of women have pulse rates greater than 95 beats per minute. So a small proportion of women, or percent I should say even, of women have pulse rates at this high number. Finally, this is the trickiest way to use the normal tables. We want to know what percent of U.S. women have pulse rates between 55 and 70 beats per minute. Again, this is a little trickier than before. Notice that we have two different pulse rates that they're referencing in this question. So this creates double the amount of work for us to do. We have to convert and find the z-score for 55 and 70. Here they are below. Take a peek. See if you can follow the math. Pulse rate of 70 has a z-score of negative 0.37, and a pulse rate of 55 has a z-score of negative 1.60. I'm not surprised by the negatives. Realize that pulse rates such as 55 and 70 are below the mean. So I would expect if I were to subtract a number smaller than our mean that we would get a negative value in our numerator, thus bringing us to these two negative z-scores. So all I did right here was, you can see that here 70 is 0.37, just a little over 0, not quite 1, and then 55 coincides with a z-score of 1.6, and if we count out the tick marks, 1, 2. So not quite 2, actually negative 1.60. So our job now is to look these z-scores up in the z-table. Now, they are negative z-scores. There are 2 pages to the z-table if you take a look at it. One page is for negative z-scores. The opposite page is for positive z-scores. Make sure you're on the page where you see negative z-scores. So again, we're going to try to find the proper row and column for the z-score. The proper row is going to be negative 1.6. That is looking at the first 2 numbers of the z-score. Here we are. The first, proper column we're going to use, if you look at our hundreds place, it's 0. So we're going to use the number here that has a 0 in the hundreds place. So they both arrive at and seem to point to the number of 0.0548. That is exactly the area to the left of negative 1.60 as a z-score. Now, if there's might be noticing a theme here, every time I look a number up in the z-table, it always indicates area to the left of the z-score I look up. So we are going to shade to the left here. The left of negative 1.60 has this area of 0.0548. Now let's go look up the second z-score, negative 0.37. So we're going to look here at the first 2 numbers. That's a 0.3. That's rather low on our list here, almost down to the bottom. So that's the proper row. And then we're going to find the proper column, which is 7. That's the 7 in the hundreds place. And they both converge upon the number 0.3557. So check out what I'm going to do here. I have chosen to use the gray brush here to shade in and show you what 0.3557 is. This tool, the normal table, always tells you area to the left. And this told us area to the left of a pulse rate of 70, which is otherwise a z-score of negative 0.37. Now notice I shaded all the way to the left as well as I could with this little tool to draw. It ends up covering up our first shaded area that was in the blue color. So what we're actually interested in is in this area that's between 55 beats per minute and 70 beats per minute. How do we determine mathematically what's this area? I just want the area that's shaded in the gray, not the area that's shaded in the double gray and blue. So what can I do with these 2 numbers here that will allow me to find the area between 55 and 70? Well, if your suggestion was to subtract the 2, you're right. If we take the 0.3557 and subtract off the smaller area of 0.0548, we'll find the exact area between those two cut points. So what this leads us to, we'll quickly turn this into a percent, and we'll discover that 30.09% of women have a pulse rate between 55 and 70 beats per minute. Well, this is our new tool called the normal table. It allows us to find any percentile we'd like using the normal curve. It doesn't matter if we're 1 standard deviation away, or as we can see here, 1.6 standard deviations away. We have the knowledge, thanks to this table, that'll give us the percentile for any number of standard deviations we would like to be from the mean.